Thanks, everyone, for inviting me. I really appreciate this opportunity. And what I'm going to talk about is I'm going to go, it's a little different than what I would normally because you guys are familiar with CCL, but I will go into some of the science. I know they tell us not to do that, but that's kind of part of the interesting part for me. Um, then why I'm involved, which actually has to do with the Arctic and ocean impacts because after I retired, I became a scuba diver.
Mm.
Pope Francis has had a really big impact on the fact that I'm involved. And it's not hopeless. Sometimes I know it feels hopeless, but it's not hopeless. So we do have the Inflation Reduction Act of 2022, and I'll go a little bit into that. Rewiring America, which I don't know if everybody has much of an experience with that, but I'm going to go through just an example. It's a really great website, and your voice matters and the role of advocacy. And then there's a few suggestions at the end. So the brief science, the impact of the Earth's atmosphere. So if we didn't have an atmosphere, then we have a perfect analog in the fact that we have a moon that has very little or almost no atmosphere. So what do we know about that? We know that it goes through tremendous temperature fluctuation in that on the sunny side, it's up to 224 degrees Fahrenheit, and on the dark side, almost 300, minus 300 Fahrenheit. So the average, though, this isn't a perfect, this is just an average of those two numbers. It's not really perfectly correct, but it's, roughly minus 37 is the average of the moon's temperature. But the average surface down here in the box of the Earth from measurements is 59 degrees. So you can see without the atmosphere, we would not be habitable. And so the atmosphere is not just for us to breathe, but it also moderates our temperatures, keeps us warmer than we normally would be. And yeah, so that's one of the big reasons we have the atmosphere. The other thing about the atmosphere is it's not very thick. It's about 100 kilometers thick, or 60 miles-ish. And it goes out to what's called the Kármán line. I mean, there is no, black and white, you're in, you're out. But it's roughly estimated to be about 60 miles thick. And when you think how the size of the world was 24,000 miles in circumference, that's like an onion skin on our planet of what keeps us all alive. And for comparison, I put this, this is actually a picture of the south coast of Texas, but I wasn't going to find another image just for Virginia. But the distance from Roanoke to Lynchburg is roughly, it's like 55 miles, but it's close to 60 miles. And so if you could drive horizontally that far, but imagine yourself going vertically, well, once you go from one to the other, you're basically then going to be out of our atmosphere. So that gives you an idea how really thin the atmosphere is. And it's not homogeneous either. So, down near the surface, I think we can only breathe up to maybe 5 or 6 miles of the first 5 or 6 miles of the atmosphere. And above that, you're going to need oxygen assist and so forth. So anyway, just it's a miracle what the atmosphere does for us and how it protects us from, the blackened space around us. So what happened? The Industrial Revolution happened. And so this kind of shows what's going back to it really started around 1800 or so. And that's when coal was produced in the UK and then in the United States, and basically Europe and the United States. And you can see this wedge of coal, the black, that was produced throughout history. And that was our primary fuel source. And then around, gosh, about 100 years ago, maybe a little bit more, that's when oil and gas came into vogue. And you see the wedge of the orange oil and the red the gas. And then nuclear took up until, back in the 1960s is when they first started building nuclear power plants. So it's that gray wedge. And then hydroelectric, depending on where you live, it can be a fairly significant part of the energy mix. And then we're now seeing this green wedge of green energy, the wind, solar, geothermal, et cetera. But, what you can notice about this, and the amount of energy is basically the integration, what's the area under these curves. So if you're as old as I am, like I'm in this 1955, 60 vintage, you can see with the explosion of the fossil fuels being produced, after World War II. So what happened? This huge mass of carbon-based fuels, of fossil fuels, disrupted the atmospheric CO2 equilibrium that had been in place for um, millennia. And this gives you an idea. Atmospheric CO2 right now is higher than any time in the last 800,000 years. And the levels are increasing faster than any time in millions of years. So this goes back 800,000, almost a million years. And you can see kind of the natural fluctuation in carbon dioxide over that time period. And if you go into a little further, my background's geology, so these actually correspond to Arctic periods. So where you have these minimums, that's an Arctic, an ice age. So our last ice age was only about 12, 15,000 years ago at this point. I don't know if you see my cursor, but you can see then we are now living in a one of these warm periods. But instead of going vertically here in an incredibly steep slope, we should be heading down back into another Arctic. And why does this happen? There's a lot of things that cause this. There's natural wobble of the Earth. The Earth's rotation around the sun is not perfectly circular, and it's oval, and there's kind of there's wobbles to that as well. So there's some geologic things going on here that causes about 120,000 years to have glacial periods. So we should be slowly heading back into a glacial period right now, but that's not going to happen given what's happening on the CO2's level. So historically, from the Holocene, that's the end of the last glacial age, which was 12,000 years ago until 1750. So that's the Holocene until the Industrial Revolution. So that previous figure, you're looking at a very thin slice of recent time. The world population changed from 4 million to about 750 million. We weren't even at 1 billion people yet up until sometime in the 1800s. But the CO2 over that time period, basically the entire time of human history, just fluctuated between 260 to 280 parts per million, which is kind of like we're in the Goldilocks. I mean, that's why everything has been so stable for so long. And then since the Industrial Revolution, 1750 to today, CO2 has increased to 420 parts per million, which is an added 50%. And that has, which causes a lot of problems. So these three curves kind of tell the story. The carbon emissions is yellow. You can see here's 1800, and you can see how they just start picking up and then really explode in the last 70, 80 years. And the Keeling curve, which you probably heard about, that's the blue part. That's the CO2, which is shown on the previous curve. And it's, as you can see, it's pretty flat, which if you would take this back would be fairly flat for a long period of time. But then that's also heading up very, very quickly. And temperatures are correlated because the more CO2 you have, the more greenhouse impacts you have. CO2 is not the only greenhouse gas, but it's one of the primary ones. So what's my background and who am I and why should you listen to me? As Diane said, I had 33 years experience. I was hired at Mobil, and then ExxonMobil kind of took us over at the year 2000. And I was an Arctic geotechnical engineer for part of my career. Geotechnical engineer is a branch of civil engineering, and it's the branch that does foundations. So honestly, goodness, I had just an incredibly great job. When we were putting platforms in offshore anywhere in the world, the group that I was in would do all the site investigations, the soil borings, the pipeline route surveys, all that kind of stuff. And I tended to work offshore for most of my career, but a portion of it was in the Arctic. And back in 1987, I got invited to go on an icebreaker into the Arctic Ocean above Alaska. And this is the people, it was a joint industry trip between scientists. I don't even remember what schools were there. It was probably about 4 universities. I think Shell, Exxon Mobil, and there were 1 or 2 other oil companies there. I'm not in the picture because I'm taking the picture, but we started at the coast of Alaska, Barrow, which now has an Indian name. They changed the name of Barrow, which is on the far northern tip of Alaska. We went about 60 miles into the ice. Um, and then we climbed down, like you can see, they got these rope ladders. We climbed down the ice, and here's one of the scientists taking an auger to the ice. We would, if you're building something, you need to know how strong it is, how fast it moves, how much force it can put into any kind of a structure, whether we were going to put some kind of big gravel island or big concrete block type structures to support, or concrete gravity base, we call them, or even floating vessels for support. You had to have anchoring systems. So it was a really fascinating problem because we didn't have a lot of ice data. So we took cores, we took remote measurements, they took like geophysics to look at the thicknesses of the ice. And I'll tell you what, it also, for me, was probably one of the most beautiful places I've ever been. And, I got to see polar bears. And this polar bear was probably about a couple thousand, about 1,000 yards away or something. And we had to get off the ice immediately. So anyway, but this is what caused me concern, the rapid change that's going on in the Arctic. And so this is a snapshot looking down at the top of the Earth. And the oldest ice is white, okay? That's what's called multi-year ice. It's there for, back then it was there for decades. Um, and then the blue, dark blue, is stuff that's called seasonal ice to lesser blue. That comes and go with the seasons. It melts in the summertime and freezes up in the wintertime. So you're going to see that. I'm going to show you a time lapse, and it's from NOAA, and it's from about 1990 until 2015. So you're going to watch the natural movement of this. It's called an Arctic gyre. It kind of goes in, I think, a counterclockwise motion generally. But these multi-year ice features were up to 150 feet thick back then, and we're talking early 80s. And obviously, that was a huge concern for any kind of structures, but we're putting structures much closer to the shoreline. So we had to be worried generally more about seasonal ice. But anyway, the multi-year ice is disappearing. Ice coverage now is lowest since the satellite monitoring started in 1979. And a historical record, it goes to the 1800s. Like, there's explorers and so forth that have records of what the ice was like over time. And then you can also get into paleo history, but I'm not going to talk about that, but you can take it back much before that without a written record. And the way things are going right now, the Arctic may be ice-free in September. That's the end of summer, as soon as 2030. But that's within the decade. And keep in mind, when you compare it to historical time, the last time it was ice-free was more than 200,000 years ago. So what I'm going to show you, I think it's now to about 85% of the ice volume. Like when I was there in the 1980s, in September, at the end of summer, it's decreased by 80% the amount of ice that's in the Arctic. So I'll narrate this. There's no audio, but we're going to look down at the top of the world. There's the North Pole, is right in the middle here. And the oldest ice, as I mentioned, is the white. The seasonal ice is the blue. And you can see the ice spitting out over Greenland, and that's what the icebergs that come down along the east coast of Canada. So here's 95, 1996. So you see this is going very quickly. But you're just not, and so that I'm working in the Arctic off and on through this time period. And you can see it wasn't changing a lot. I mean, I was in a group that we would get, yearly reports, and this is about the time I left. So when I saw this video, watch what happens now. Watch the multi-year, the white ice disappear. where, look at that. It's almost complete. Multi-year ice is almost completely gone. And when I saw that, frankly, I was stunned. I had no idea, since we weren't involved from early 2000s because, it was just too expensive to even bother considering producing oil from up there. And I just couldn't believe that that actually happened over such a short period of time since the early 2000s. So why does that happen? This is just one map. What it shows you is that the temperature increase is not even across the world. I mean, you hear about the Paris Accord and the 1.5 degrees or 2 degrees centigrade. It shows you that there's a lot more heat concentration for whatever reason at the poles. And I haven't really read up on it, but there's scientific reasons for this, but that's beyond my comprehension. But you can see that in the lower latitudes, it's more the increases are closer to 1 degree C or less. And then this tells the story real well, the rapid warming. And this is coming from NASA. So since 1980, and this goes back to comparing the temperature to the 1951 to 1980 average. So you can see in 1980 here onwards, you see globally, the temperature is approaching one. Actually, we're somewhere now between 1 and 1.5, okay, which is consistent with this graph. But the Arctic is already well above 2. And we don't hear much about that because nobody lives up there. And unless you, I guess, worked up there, you don't worry about it. So this to me was stunning, just for a single word to describe it. I was just blown away when I saw some of this. Okay, so I retired around 2013, and really one of my really good friends talked me into scuba diving, which was just, I mean, I'm really glad he did. So I started in 2013 just to see the incredible marine diversity. These are all shots from Cozumel. This is where, it's not too far from Houston. And it's a good place to dive, and it's not that expensive. I mean, when you get there, it's like being in an underwater zoo, or, a fish tank with thousands of species of fish, coral, sponges, crabs, everything, and it's a symbiotic ecosystem. So right here, you see the turtle is actually eating coral. The coral is alive. This is a parrotfish. They also eat the coral. You can hear them crunching on it when you're diving. And so they all kind of, they exist because it's a symbiotic. They rely on each other. But reefs are in decline. Bleaching is correlated to warm waters, stressing the corals. And by the way, all that excess heat that the CO2 is producing, 90% of the excess heat goes into the oceans. So that's why the oceans are warming. But the volume is so huge that they do warm, but it takes a while. But the world's reefs are significantly declined over the last 30 years, which it's basically the same thing we're seeing in the Arctic the same time period. So mass bleaching events have happened in these years, and I'm talking about the Great Barrier Reef in Australia. And this is a picture from National Geographic of a healthy reef, and you can just see the beautiful colors, and that's accurate. I mean, it's that beautiful. And this happens virtually overnight. When the temperature spikes over a period of time, the corals die. When the corals die, because of the way, it's a symbiotic system, the other species can't survive. And this is what's amazing. The Great Barrier Reef, which is this green area on the northeast part of Australia, if it was a landmass, it'd be the same size as Italy or Japan or even Germany. 50% of the Great Barrier Reef bleached in the two key years, 2016, 2017. I don't know what happened in 2023 last year, but I know it was a bad year. So it may be another really bad year, but it's over 50% of the Great Barrier Reef is now gone. And that's kind of like saying half of the Amazon's gone, to give you an idea, because it's corals are where a lot of species of fish spawn, and it's incredibly productive ecosystem. And so what we're seeing is ecosystem collapse. But it's kind of like, I don't understand why it's not really more people, or it's not a bigger news item, because I think it's kind of out of sight, out of mind. It's underwater. Nobody sees it that much. And the diving community obviously is very upset, but it just doesn't get a lot of press. So now I'm going to go into the influence of Pope Francis, because this all ties into the same time period, the kind of the 2015-16 time frame. He issued his landmark encyclical Laudato Si in 2015, and he didn't just go off in a corner and seance with the Holy Spirit or something and come up with this document. He was advised by the Pontifical Academy of Sciences, and that academy dates to the 1600s. And it's many Nobel laureates have been a member, 70 alone since 1902. And his commission had, I can't remember, I think there was at least 5 or 6 Nobel laureates on this. And he's a scientist by training. Before he became, went into seminary, he actually was I think he's a chemistry major. But so I would, and the other thing was interesting, when I had a friend who was really trying to recruit me for CCL, he handed me a copy of my first, or a copy of Laudato Si at my first CCL meeting in 2016. He said, "Have you read this?" I said, "No." I did, and then pretty much changed my life. But consensus, it's an easy book to read. That's the other thing. If you ever seen anything written by John Paul II, you need a translator to help you read it. Pope Francis writes in a very readable writing style. So it's an easy book to read. It's only like 90, 100 pages long. By the way, the consensus basically is climate change is real and is caused in significant part by humans. So here's my condensed summary of Laudato Si. We are responsible to protect creation and all people, particularly the poor, who contribute least to climate change, but are disproportionately impacted by it. It's a moral challenge to renew our relationship with God, one another, and the created world and mankind. And he's talking not just to Catholics, he's talking to all faiths, believers and non-believers. We should immediately take concrete steps to reduce consumption and CO2 emissions and do a better job of caring for creation, as emphasized by St. Francis of Assisi. So he's a real hero of mine. I can't say that he's been as successful as I wish with the Catholics. That's another topic we could go into someday. But that's it. Unfortunately, a lot of people of faith look to their political agenda more than they do their faith. Anyway, many other faiths are also speaking out. And so it's not just Catholics. And I've been fortunate. I've given a presentation in Church of Christ, Unitarians. I even gave to a Muslim group once when that was interesting. Episcopal. So there's a number of these that I've been able to give presentations to. But if you look up before I go, I always try to see what their, like their bishops or whatever are saying. And these faiths are all on board, kind of echo. They don't have the same platform that the Pope does, but they're saying the same things. So why does this matter to me? And you can't go through a presentation without seeing a picture of my grandkids, and that's too bad. But all my grandchildren have been born after 2012. Starting in 2013, I became a grandfather. And every year after their birth, it's been increasingly hot. And this graph is just enough to make you cry, honestly. But you go back to 1940, and this is compared to 1850 to 1900. It all depends on what you compare it to. But this is the average for 1850 to 1900 comparison. So you can see how the temperatures are pretty stable through, early 1980s, even maybe almost 1990. And then you can see this is steady increase in temperatures ever since. The 20 warmest years in recorded history have occurred in the last 22 years. That's not counting I think that does count 2023. Here's the thing. 2023 was the hottest year since records began by a large margin. And I'm not sure they completely understand why it was such an outlier. But last year was incredibly hot, particularly if you're in Houston. It was brutal last summer. But it's not hopeless. Progress is being made, and I'm going to get into the role of advocacy. I'm preaching to the choir kind of on this part because you're all members of CCL. But I'm just going to do kind of a brief overview of the Inflation Reduction Act. It's the largest climate bill in U.S. history, 369 billion of clean energy funding, and it will help reduce U.S. carbon emissions by, I mean, the target's 40%. Will we get there? Probably not, but we're going to get close, I think. It's less than the Paris goal of 50%, but it is a really good start. It incentivizes clean energy, electric cars, electric homes, and it also moves a lot of American manufacturing back to the United States and invest in green technologies to help ramp up manufacturing. And I think there's ample evidence that that's really working. A lot of this stuff is now, like even solar panels and things like that are now being produced more in the United States than they were in the past. So it's going to transform our economy. So the targets for 2030, up to 85% of our electricity will be from clean resources. And that's going well, primarily because of solar panels, and the cost has gone way down. Clean power production from solar, wind, and other clean sources will triple. Even if it doesn't triple, we're making really good progress. Maybe more or most new cars and trucks will be electric. I know there's some hiccups along the way, but we're definitely making progress. And if we're not, the Chinese certainly are. They're doing really well. They produced more electric cars last year than the world combined. And there's at least 1 million new jobs will be created in clean energy manufacturing. So there's a lot of jobs here. So you all know about the four policy areas, the carbon pricing, healthy forests, et cetera. This is the one I'm just going to kind of highlight tonight. So why do we go electric? First off, money. You can save a lot of money. If you electrify more things, you can save up to $1,800 per year on average by going fully electric. Burning fossil fuels is a way it causes a lot of health problems, like childhood asthma. So if we can reduce that, that's going to only help from a health regard. On the climate, fossil fuel burning in buildings is also a major source of climate pollution. And here's one that I just, and there's some really nice graphs here to show how we can protect against wild fossil fuel price fluctuations due to political and worldwide disruptions. There's a lot of stuff now, and it really irritates the heck out of me, where it's like, drill, baby, drill, we need more. America's production of oil and gas is at its highest level ever right now. And that there is no domestic market for oil and gas. It is a world market. So when things happen in the world, our prices go up and down. When the war in Ukraine happened, our prices went up. Nothing we can do about that. Doesn't matter how much we drill, it doesn't matter how much we produce. So that's such a fallacy, and it becomes a political football. But we do not control prices. And if you work for an oil company, you certainly understand that. I went through incredible. I mean, to survive 33 years when prices are always going up and down, and they're laying off people left and right half the time, it's an interesting industry. So here's the percent change in electricity rates. All right. So you can see how electricity, it fluctuates, but not by a whole lot. I think the whole range there is about 20% over a 20+ year period. Let's throw on top of there natural gas. Look at the fluctuation in the price of natural gas over that same time period. And now let's throw on top of that gasoline prices, which is, I think anybody that buys gasoline understands the crazy up and downs of pricing. Like, I think prices down here were 20 cents, 25 cents cheaper a couple of weeks ago. I don't know what the reason for the spike is right now, but something's going on in the world causing that. Here's the other thing. And when someone gives me a hard time about having a plug-in hybrid or having panels on my house, I say, hey, sunshine and wind price. What's the price of natural gas and going to be in 20 years? Tell me right now. And they'll say, I don't know. Well, I can tell you what the price of wind and sunshine is going to be. It's the same as it was, 40 years ago. It's going to be the same in 60 years from now. Zero. And it's changing by 0%. Okay. You have a high upfront cost, but you have zero fuel costs. And I'm saving a lot of money. And I think people will figure that out over time. Incentive mechanisms linked to the IRA. You can either pay in advance and get money and get your money back. If you pay, then you get the money back whenever you pay taxes. Um, Rebates, they're provided up front. So people with less income would much prefer, obviously, getting rebates than getting tax credits. So if you haven't seen this calculator, and I'll put it in the chat afterwards, but this is a really tremendous tool. The IRA has a wide range of home electrification incentives, and you can go into this and everything is regionally adjusted. To do work in California costs different than it does in Iowa or West Virginia, right? So it's regionally adjusted. It's also adjusted for income level. Upfront discounts, rebates are skewed toward those with low incomes because they don't want to wait a year to get their money back. Incentives shift to tax credits for higher income people and families, and the end result is lower energy costs per year for all households. So let me ask you, I'm going to just click on this. And I put in Roanoke as an example. So anyway, I put in the Roanoke zip code here. And I said I'm a homeowner and my household income is 65,000. I'm married, filing jointly. This is all things that when you go in yourself to this, you'll go straight to this thing, and it'll say, "What's your household size?" And then you just hit calculate. I'm saying it's a 4 people family, and this tells you what's available coming from basically from the IRA. And it says, okay, here's your personalized incentives. Upfront discounts of $14,000. That means the money that you can get back. I don't know how that works, but you can get the money back quickly, like when you start working with a contractor to put in a heat pump or whatever. And then there's tax credits that some you still have to wait to get the tax credit. But this will bring you to $1,450 of savings per year. So it gives you the total incentives. And there's a lot of things you can do that we don't have time to go into, like frequently asked questions. You can check into it. But it gives you a nice list. Here's the things that you can do and get the rebates. Put in a heat pump, upgrade your electric panel, weatherization of your home, and it says how much the government pays to help you do that. And it says timeline, I think, really means that's when the rebate becomes available, which they're all available starting. Some of them weren't available last year, and some of them just started being available this year. And here's the tax credits, uh, battery storage, new electric vehicle, for example. Okay. So anyway, you can go look at this and do your own, you put your own income in there, you put your own zip code and whatever your status is, whether you're single, and there's the other things, if you rent, there are still things you can do when you rent. And I haven't looked at that in any detail, but there are things you can do. So I'm going to do another one real quick, just to show you the effect of someone's making, let's make it 265,000 and recalculate this. So there's no upfront discounts. That means if you make that salary, that means everything you do, you got to pay for it up front. You'll get it back through a tax credit. Same amount of energy savings, but the total incentives is 31,000. And here you just see a comparison. New electric vehicles, you get $7,500 back. Solar rooftops, you get 30% of the cost of the rooftop. Solar weatherization, $1,200. It's the same thing. I don't even know what efficiency rebates are, but as you can see, here's more information. But okay, so I gave a presentation last year, and I had a couple real climate denier detractors in the crowd. But when I put this up, they couldn't write notes fast enough, and they became very interested in what I was talking about. It was fascinating. And Rewiring America also has this thing, an electrification planning tool. But I'm not going to go into this because it'll take a little bit of time. But it basically says you put your information in there and what you want to do. I want to lower my energy bills. I want to lower my climate impact. And then it basically says here's the things you can do, and it lets you come up with your own plan over several years on how you're going to, obviously you're not going to do everything at once. So it lets you set up a schedule on staging things and also, I guess, planning on how you're going to get your money back and all that kind of stuff. And that's new. And it's also a really nice tool. And it said for me, the first thing I need to do is rewire my home to get it ready for things like induction stoves or heat pumps, etc. And then the second list they give you is recommended projects. And these are the things that said I could do for this is my particular case, but yours will be different. This is CCL kind of in a nutshell. But I tell people, if you're comfortable, you can't be comfortable. You got to engage yourself as an advocate if you want to change anything. So, we want you to become an advocate. We want you, act locally, share what you know about climate with friends and family, even, grouchy Uncle George who doesn't want to listen to you. Consider pushing for climate legislation. And I'll usually tell them about, lobbying is actually, I was petrified when I first did it, but after a while, it's actually a very enjoyable activity. But if you don't want to become an advocate, these are all the things you can do: ditch your grass, weatherize your home, trade in for an electric car. This is a big one. Get rid of your ancient appliances. You can save a lot just by going to Energy Star. Don't pre-rinse your dishes. Dishwashers are made now to wash, save on water. Get a smart thermostat. Stop washing clothes in hot water too. Um, switch to LED. Eat less meat, beef in particular, and share these ideas with friends and family. And there's the world's littlest book on climate. I'll try to get that in the chat too. So that's it. I say, here's more information. Thanks. And I usually finish with that one because I like that. So.